Here we are, number 4. We got a 1600 ampere 3-phase 208 120 volt service in a commercial building, has a single fusible main switch, and is supplied with 5, count them, 5 parallel sets of 500 kcmil ungrounded conductors. The minimum size for the main bonding jumper, or MBJ, is what gauge or kcmil. This is a good one to do because it is going to exceed the table values, right? So we can see how that calculation works. So the first step when we are sizing that main bonding jumper, as we have done a few times before, is we are going to want to turn those parallel sets into one large conductor. Okay, that's the easiest way to do it. Okay, so we can always cruise over. What's that reference on that one? That's going to be 250.28D. That's going to tell us kind of our instrumental pieces of information for how to size this. But just for the purposes of the calculation, let me slap it out for you. I had 5 parallel sets of 500s. So I'm going to do a little math on that. I'm going to turn them into one large 2500 kcmil conductor. Okay, and then it's as simple as heading over to our table. We're talking about the main bonding jumper, so we are going to be in 250.102C1. Okay, and then we're just going to go down and find the main bonding jumper that's associated with 2500 kcmil, but we don't have one specifically. We do, however, have this over 1100 section at the bottom, and it's going to tell us to see notes 1 and 2. So let's make use of note 1 right here. Note 1 says, if the circular mill area of the ungrounded supply conductors that are connected in parallel is larger than 1100 kcmil copper or 1750 kcmil aluminum, the grounded conductor or bonding jumper shall have an area not less than 12.5% of the area of the largest supply conductor or equivalent area for parallel supply conductors. Okay, so we are just going to take that 2500 kcmil, and we are going to multiply it by 12.5%. So we'll do times 0.125. Just move that decimal over a couple places to get it, like we've done several times in the past. And then let's punch this out. So we have 2500 times 0.125 equals 312.5, and this is going to be expressed in kcmil. So we need to find a conductor that is at least 312.5 or 312,500 circular mils. Okay, now for the sake of saying this, I'm going to jump over and look in the appropriate section, even though we can kind of surmise in our head that it's going to be a 350, right? We can come to that conclusion in our head. But in the eventuality that we don't have a nice even number like that to work off of, you're going to want to take a look in Chapter 9, Table 8. Okay, because there could be situations where you're going to run this calculation or some calculation that's similar, and you're needing to find a conductor that is not broken out of the kcmil category. Okay, and remember, you have in Chapter 9, Table 8, a whole section on circular mils. Okay, so you're going to want to do a little cross-referencing here if you need to. But for the purposes of this question, 312,500, the next size up is going to be a 350 kcmil. Okay, 350 kcmil should fit the bill. Number 4, Echo, nailed it. Okay, sound good? See how we got there? Nice job.